Empirical and molecular formulae. Empirical formula is the simplest form of the formula. It's like if you reduced a fraction. So like if you had 4/8, it's actually a half. You might actually have 4 little tiny pieces that would have made up 8 if you had all of them, but it's still a half. So when we're talking about the empirical formula, it's the simplest version of the formula. We'll go through some examples. The actual or molecular formula shows you exactly what you have. So if this was a fraction, empirical would be a half, molecular would be 4/8. When we're talking about chemistry, if I have CH2, that's the empirical formula. It may also be the molecular formula if I just have 1 carbon and 2 H's. But if I have H8, then there's still 1 carbon for every 2 hydrogens. So that's the molecular formula for that particular thing. But its empirical formula would be CH2. All right, so we're going to do some work with that. The examples that they show you is you're supposed to be finding the empirical formula of a compound if you know what the percent composition is. So let's say I have 80% carbon and 20% hydrogen. Now this is example 1 on page 91. So I'm supposed to be figuring out what the empirical formula is. So basically it's a ratio. What I want to do is, because I'm working with percents, and it doesn't give me an actual amount, and the amount doesn't matter because I'm just dealing with ratios, then I can assume a convenient amount. And the convenient amount for me, because it's percents, is 100. So I'm going to assume 100 grams. So assume 100 grams for any substance that you're doing this with. Now that means that I have 80 grams of carbon and 20 grams of hydrogen. Of course, I know the molar mass of carbon and I know the molar mass of hydrogen, so I'm going to use those to help me figure out actually how many carbons and how many hydrogens I have. So the easiest way to do that is I'm going to set it up down here. I'm going to go carbon is 80 grams and hydrogen is 20 grams. How many moles do I have of each? Well, I have grams, I need moles. I'm going to use the molar mass to connect them. So I'm going to go the molar mass, I could even write it up here, the molar mass, of that is 12, and the molar mass of hydrogen is 1 gram. So this is per mole, right? 1 gram per mole. So if I figure out how many moles there are, then I should know what the ratio is. So I'm getting rid of grams, and I want to get moles, so I'm going to arrange my units so they cancel out. There's the 12, and that gives me 6.67 moles of carbon. Down here I do the same thing, 1 mole over the 1 gram per mole, and that gives me 20 moles of hydrogen. Now, does it make sense that we have more hydrogen than carbon? Yeah, it does. Because even though it's a smaller amount here, hydrogen weighs considerably less. So, what I want to do now is go, okay, I have these big numbers. This is 6.67 to 20. How do I reduce this ratio? Well, usually the easiest way to reduce a ratio is just to divide by the smaller number. So if I go It's like saying 6.67 over 20 equals 1 over what? So I can go 20 times 1 divided by 6.7, however you want to. We've got lots of ways to solve these things, but we're basically just going to divide by the smallest number. So it's going to give us 1, and 20 divided by 6.67 will give us 3. It's actually quite nice and tidy. So that means I have 1 carbon for every 3 hydrogens. Therefore, I can conclude that my empirical formula is CH3. Not my molecular formula. That could be different. It could be C2H6. But for every 1 carbon, I have 3 hydrogens. This is the basic ratio. That is the empirical formula.